Hey everyone, today we are going to break down a real world production Docker file that you can actually use in your CI/CD pipeline. So this isn't a simple Node or Python app container. This is a build agent, a container that builds and deploys other projects. So let's go through it layer by layer, right? So we'll start with a base image, right? I'm going to use Docker 27-CLI. Now, this is important. We are not using Ubuntu or Debian here. We are using an Alpine based Docker image. Alpine is a tiny Linux distro around 5 MB, which means our final image stays lean and secure. So next we are going to use arg and env, and arg is something that gives you a secure build time input, and env makes it available at runtime. Our arguments and envs are set now. In a real pipeline, you would inject these from your CI tool, any tool like Jenkins, GitHub Action, or GitLab. This way, they are never hard coded. This is the right way to handle secrets in Docker, basically. Next, we'll move to installing system packages using APK. So we run APK upgrade followed by APK add, right? Instead of apt or yum, we are not using that here because we are using an Alpine image. We are installing some packages like Linux headers, Perl, Bash, Git, Ansible. Read about these packages, why they are required. So these packages might differ according to your use case. Important thing to note here is that we are using only a single run instruction here. This is very critical. Every run instruction will create a new image layer. If we will split this into multiple run instructions, will also be a separate image layer. So this will increase your Docker image size. So don't have multiple run instructions. Try to avoid. Next, we'll install Maven. We have Spring Boot applications running within our organization, so we need Maven to build those applications. We'll set some environment variables. Version I'm using here 3.9.11 Java version. M2. So I'll have another run condition here and we can go through it. We are just calling this, and it will install whatever version you have defined above here, that is 3.9.11. And then we are moving it to our M2 home path command that we're using to basically do a smoke test whether the Maven is installed or not. If this command fails, your Docker build will eventually fail. Right. Next, what we'll do is we'll install some Python packages. We use ---- break system packages flag. So this is required because modern Linux systems protect their built-in Python from pip. So this flag is just you telling pip, yes, I know what I'm doing. Go ahead and install. This is safe to use inside Docker since it's an isolated container anyway, right? We are going to install JFrog CLI. This is for artifact management. And in another run condition, I'll have to use curl. This is how we install JFrog CLI, and we'll also create a work directory. You can have any script that you want to copy. We have settings.xml, entrypoint.sh. So settings.xml is a Maven's config file. So this is required to point Maven at a private JFrog artifact registry. Maybe in the next video I'll show you how you can configure this file. So in summary, this container is a fully self-contained CI build agent, and as you can see, we got one error. So I don't have these files in my local as of now. Comment it out and then try to build it again. It will be able to build that image. It has picked up some cache layers because I have built this image already in my system. I was just trying to show this to you. So you can use this and drop it into any pipeline, and it can clone the code and build Java projects with Maven, run Python and Ansible automation. It will be able to parse the any configs using JQ package. You will be able to push your build packages to JFrog using JFrog CLI. This is all in one image, right? That's the power of well-designed Dockerfile. I'll put the link in my description below so that you can have a look. Thanks for watching. See you next time.